I'm going to start by showing you a predictive coding calculation on 1.3 million documents from Wikipedia totaling 3.3 gigabytes of text. We see our usual clusters by size view to start. I've already taken a random selection of 300 documents and tagged them as being relevant if they are about sports and as non-relevant otherwise. That will be our control set, so those documents will not be used for training. Let's load the control set. As we review training documents, we'll be able to see how the predictions for the documents in the control set change. And we'll see how well the predictions line up with the tags that we've already applied to the documents. We see that the relevant score values are 0 for all of the documents in the control set because we've not yet reviewed any training documents, so the system does not know how to score anything. The documents are sorted by score. When we start reviewing training documents, it will update the relevant scores and resort the documents. The relevant documents will have an orange tag by them, and the non-relevant documents, the ones that are not about sports, will have a blue tag. The relevant documents should float to the top as the system becomes trained, and the documents with a blue tag, the non-relevant documents, should sink to the bottom. The keywords column shows you a few keywords from the text to help you navigate the documents, since the document names are often not very meaningful. The precision recall curve is pretty flat and stuck down around 10% because the prevalence for this document set is about 10%. Roughly 10% of the documents are relevant. As we train the system and the predictions improve, that curve should move up towards the top to indicate that the software is doing a good job of separating relevant documents from non-relevant documents. Every time I review a training document, you'll be able to see the relevant scores update. The ordering of the documents in the control set will change, and the precision recall curve should shift. So let's review some documents. I'm going to move the curves around, or move the windows around so that you can see everything. So I can tag the documents using the mouse, or I can use the keyboard, just hitting Y or N. And you can see the precision recall curve moving a tiny bit, and the documents in the control set shifting around. When I review a relevant document, or first relevant document in the training set, you see that the precision recall curve jumps a lot because it finally has some idea of what a relevant document looks like. So if you take a look at our control set, you can see that a lot of the relevant documents, the ones marked in orange, have moved to the top of the list. But there are still a few that have not made it. You can also see that many of the documents still have a score of 0, meaning that the software really does not have any idea how to categorize those documents yet. And that's reflected in the progress pie. The white section of the pie means that represents documents that are not well understood. So we still have not trained the system very thoroughly. We've only reviewed 20 documents out of 1.3 million. You can review a few more documents. It is important to note that the scores of all 1.3 million documents are updated each time we review a training document, not just the predictions for the documents in the control set. The progress pie is based on the entire document population. That's real-time predictive coding, so you see the impact of each individual document. You don't have to complete a batch of documents to see results. For this document set with 1.3 million documents on a modest desktop computer, it takes an average of 1/10 of a second to update all of the predictions each time you apply a tag to a training document. Speed will depend on your dataset. The system isn't fully trained at this point, so it is a bit early to do this, but let's ask it to give us 500 documents that it thinks are highly likely to be relevant. If we scroll through these documents and look at the keyword labels, it's pretty clear that most of these documents are about sports. Suppose we start tagging these documents. And we tag one incorrectly. Clustify has put a yellow warning icon adjacent to the document that it thinks is not tagged consistently with how we've tagged other documents in the dataset. The intensity of the warning icon indicates how confident Clustify is that I got the document wrong. Again, the warning icon is displayed in real time, so we get the warning while the document is still fresh in our minds. We can get a list of the documents that the software thinks have been mistagged at any time using the Docs with Dubious Tags menu item. I'm going to switch to a different dataset now to show you the next feature. I'm going to show you the new Shadow Tags feature. This is a really great way to do experiments and see how the software works. The dataset we're going to use for this is 100,000 magazine articles. These documents have all been tagged by a human reviewer, and documents about biology have been tagged as relevant. We can simulate a full document review using shadow tags. Shadow tags are loaded into memory, but are not applied to the documents until we generate a training set or control set. Then the documents in those sets are tagged automatically using the shadow tags. So it's like having a human apply hundreds of tags, but it happens in seconds. I'm going to generate a control set. This time I'm going to use 10,000 documents in my control set, which is a pretty large control set, but I want to have a lot of detail in the precision recall curve. Let's do some training. I'm going to select 100 documents at random. And so the software has automatically pulled the tags for those 100 documents from the shadow tag list and applied those tags to the documents. And I can see my precision recall curve. Let's do some more tagging. Let's tag another random 100 documents. I can see that the precision recall curve has improved. And I can continue to do training, and it should continue to improve. So what we just went through was a simulation of reviewing 300 randomly selected documents and looking at how the precision recall curve evolved. We didn't have to go through a lot of hassle about importing tags or anything. It was all handled automatically in the background with the shadow tags. Now let's experiment with a different approach to training the algorithm. I've loaded a second copy of the same data, and I'm going to load the same shadow tags. And again, I'm going to use a control set with 10,000 documents. And we'll put our old random sampling set over to the right for comparison. And now I'm going to train using smart sampling. So instead of 100 random documents, I'm going to use 100 smart sample documents. Smart sampling is an active learning algorithm. It tries to strike a balance between probing untested regions of the concept space and refining the boundary around the relevant documents. If I do some more training, for this particular task, the smart sampling did considerably better than the random sampling. At 70% recall, the random sampling is giving about 20% precision, while the smart sampling is giving about 56%. If we look at the progress pie, we see that smart sampling has made more progress, but both are pretty undertrained. The white wedge representing documents that are not well understood is still pretty big. We've only trained with 300 documents, which is only 0.3% of the document set. Suppose we decide we are happy with the precision recall curve at this point, and we want to start reviewing documents that are expected to be relevant. Let's take 500 documents. We select likely to be relevant. Keep in mind the software is predicting which of these documents are likely to be relevant without knowing what the shadow tags are. And then after it makes that prediction and picks the 500 best documents, the shadow tags are applied so that we can see the result. So this would be similar to a human reviewer getting those 500 most likely to be relevant documents and going through and tagging them all one by one, and then we look and see were they in fact actually relevant when the software predicted that they would be. If we scroll through the documents, we see that the vast majority of them are in fact relevant. They have orange tags next to them. So we could repeat this procedure. Looking for the 500 documents that are most likely to be relevant after we removed the previous 500, and we actually used the previous 500 as part of the training for finding the next set. And again, the vast majority of them are relevant. We start to get some that aren't relevant as we get down towards the bottom. We could continue this procedure until we stop getting a significant number of relevant documents, and then test the remainder to verify that there aren't many relevant documents left. Shadow tags allowed us to simulate several iterations of training in a matter of minutes and test various training strategies.